I'm Nur Izzah binti Nazaruddin.
Hi, I'm Puwenji.
Hi, I am Faris Irfan.
Hello, I'm Yongwei.
Hi, my name is Muhammad Haris bin Abdul Hamid.
Hi, I'm Jermaine. Hi, I'm Nurul Akila Ibrahim.
Hi, my name is Muhammad Zikri Izzuddin bin Hamdan, and we are from Group 6. Today, we are going to present to you about humidification and its application.
Now, we will start with introduction and the definition of humidification. One of the earliest use of humidification was in 1 BC. It was built in Rome. Thermae, or Roman baths, uses aromatic humidifiers. The water in the bath has aromatic content, which was humidified by the furnace beneath the wooden floors. And since then, the technology of humidification has grown significantly. By Cambridge Dictionary, humidify is to make dry air water. So, humidification is a process of transfer of water from liquid phase into a gaseous mixture of air and water vapor. There are 3 types of humidification. Comfort humidification, which is to bring better environment to a living or working space. Process humidification, to produce and process and also to keep high quality standards. And last but not least, spa and wellness, such as steam sauna and spa.
Next, we will focus on a water cooling tower. So, what is a water cooling tower? Water cooling tower is a specialized heat exchanger in which air and water are brought into direct contact with each other in order to reduce the water temperature. In industry, it is important to cool down the water that gets heated up by the industrial equipment. So, how the water cooling tower works? Cooling tower system work by using the water to extract waste heat from a system and ejecting it into the atmosphere primarily to the evaporation. There are 3 key components of a cooling system, which are the cooling tower, the circulating pump, and heat exchanger. The principle is water first passes through a heat exchanger where it absorbs heat. Then, the water distributes over the top of the cooling tower where air travels past the warm water, causing a portion of the water to evaporate. The heat from the water stream is then transferred to the air stream, resulting to raising of the air temperature and its relative humidity to 100%. This warm air is then discharged to the atmosphere, resulting in a cool water stream. The cool water from the basin is then pumped back through a heat exchanger and the cycle repeats.
Humidification is the process of constituting the water vapor content in a gas. When a gas is brought in contact with a pure liquid in which it is essentially insoluble, interface mass and heat transfer takes place simultaneously. The device or reactor where humidification happens is known as humidifier. In humidifier, it basically consists of a motor for the airflow and a humidifier surface, which is in direct contact with the water which is supplied via a tank system or a water supply device. Let's see an example. First, the air will flow into the humidifier. Then, the air will be in contact with the water. At this moment, water either takes significant heat and turns into vapor or evaporates itself due to low humidity in air. Next, as the water vapor separates from liquid, it is carried away passively or actively. This is mass transfer process. The water vapor is then transported by the airflow out of the outlet. As a result, outlet air has become more moisture and has higher water vapor content than the inlet air.
For the dehumidification process, generally is about to remove moisture from the air. Dehumidification process is the process of removing moisture, water vapor or humidity from the air while maintaining its dry bulk temperature. Based on the graph below, it comes with cooling and heating of the dehumidification process. There are 2 basic dehumidifying working principles. First, extract moisture from the air, like most air in the house being condensed by evaporator and end up with a cold but dry air. Second, heat the dry air back. The cold air going through a condenser to increase the temperature in the house. Next, how the humidifier works. First, the compressor propels the fan and flow of the refrigerant. The humid air will go to the humidifier by an inlet. The moist air will go to cold coils and the water from the air is condensed. Then water will be collected by drip tray in water tank. Cold air will go over hot coils to warm up. The same fan that draws moist air in the humidifier will now push the dry air out.
Next, we talk about the calculation. At first, we learn about the humidity chart. The dry bulb and the wet bulb temperature will be given, and we have to draw a vertical line from the wet bulb temperature to the 100% of the humidity. Then we have to draw another parallel line to the adiabatic saturation curve. Next, we draw another vertical line from the dry bulb temperature that made with the parallel line. The intersection point will be the humidity of the air that we need to find in the step 1. For step 2, we have to determine the enthalpy at the bottom of the humidifier, which is Hy1 from the equation that given. Since the H1 already found in the step 1 and the equation can be solved. So for step 3, we have to find the Hy2. This is the enthalpy at the top of the humidifier. So in this equation, all the unknown have been given and find except the Hy2. So the equation can be solved.
The fourth step is to plot an equilibrium line. The data of humidification equilibrium line is fixed where it can be found from table 10.5-1. The liquid temperature is x-axis and the enthalpy of mixture is y-axis. After that, draw the operating line by plotting TL1 Hy1 and TL2 Hy2 on the same graph. Then, draw a straight line to connect 2 points as shown in the diagram at the right. Coming to the more complex steps. 6. Plot several lines with this slope. If your memory serves you well, mP is molecular weight of air, Kg is gas volumetric coefficient, and P is pressure. To plot these several lines, first randomly select points lines on operating line. By using the theory of gradient equal to y divided by x, random pick another point x, then calculate the corresponding y. Draw a line to connect 2 points. Continue to step 7. Obtain several HYI and tabulate these patterns. HYI is point lines on equilibrium line at the slope calculated just now. Next, plot 1 over Hy minus Hy against Hy from the range of Hy1 to Hy2. Find the area under the curve by applying numerical integration method. Last, we can calculate the Z, which is the height of humidification tower required. It can be either calculated by using small k from mass transfer coefficient or big K overall mass transfer coefficient. Both give same answer. In short, calculation is extremely important as it ensures the humidification process can carry out safely under customized conditions.
4. Applications. General applications. Humidifier or dehumidifier can be advantageous to human health. This is because humidity levels above 40% rapidly deactivate virus particles, making them much less likely to be infectious. Another application is refrigerator as food storage. With controlled humidification, food can stay fresher for longer and storage times can be prolonged. Dehumidifier in a refrigerator. The diagram shows the flow of how dehumidifier works in a refrigerator. Method of cooling in a refrigerator. Firstly, refrigerators cool by pulling in air from inside the food compartment and blowing it across a series of copper coils filled with refrigerant. This reduces the temperature of the air. The refrigerant absorbs the heat in the air and is pumped down to coils on the bottom of the refrigerator. Next, as water vapor condenses on the coils, it drips down into a drain, which removes the water to the bottom of the refrigerator, where it collects in a condensate pan. So, what would happen if the air in the refrigerator was not dehumidified? Water vapor would condense on the walls and ceiling of food compartment. Over time, this would lead to mold and mildew growth, as well as contributing to food spoilage.
Moving on, for the application of humidification in industries, there are several reasons why humidification is important. Firstly, it is to reduce static electricity build-up. static build-up occurs when the moisture levels are too low. Second, to preserve inventory, equipment, and buildings. Third, to maintain product quality. There are many examples of humidification process in industries. One of them is the humidification and dehumidification process for the desalination of water. But first, what is HDH desalination? HDH desalination works like a rain cycle. It vaporizes water from a saline liquid stream into carrier gas stream and then condensing the vapor to form purified water. How HDH desalination cycle actually work? Let me explain in detail. A typical HDH system consists of a humidifier, a dehumidifier, and a heater. For the step-by-step process, firstly, cool air will enter the humidifier where it is exposed to hot saline water, which increases the temperature and water content of the air. Then, the hot moist air enters the dehumidifier where it loses heat to a feed stream of cold saline water flowing through a coil. Lastly, water vapor condenses in the dehumidifier and exits the stream as a stream of fresh liquid water.